This lecture deals with Bresenham's line drawing algorithm. As you all know, line drawing algorithms will be based on the slope-intercept equation y equal to mx plus b. Now, this algorithm actually proceeds based on a decision parameter pk. So, our aim is to derive the decision parameter pk. So, let us consider line with positive slope with m less than 1. M less than 1 in the sense, if you consider slope, that is dy by dx, and if dy by dx is less than 1, then that means dx is greater than dy. So we are considering line with positive slope with m less than 1. So dx is greater than dy, and we are going to sample x at unit intervals and determine the corresponding y value based on the decision parameter pk. So let us consider this particular situation. So assume that at kth step we have plotted the pixel xk plus, at kth step we have plotted the pixel xk yk. So this is the pixel. Now at k plus 1 step, the pixel to be plotted will be either xk plus 1 yk or xk plus 1 yk plus 1. So let this be the this be the point that actually syncs with the pixel center corresponding to xk plus 1, and the corresponding y value, let it be y. So the point xk plus 1 y is on the actual line path, but our question is which pixel to be selected. So that depends upon the distance d1 and d2. So if d1 is lesser, then that means the lower pixel, that is pixel in the scan line yk, is closer to the actual line path. And if d2 is lesser, if this distance is lesser, then that means the upper pixel, that is pixel in the scan line yk plus 1, is closer to the actual line path. So at k plus 1 step, it is clear that the x value will be xk plus 1, but y value could be yk or yk plus 1, and that is dependent on this distance. This line need not pass through the exact pixel center in the scan line yk plus 1 or yk. That will be in between these two pixel centers. So you have to measure the distance and you have to check which pixel is closer to the actual line path, and that pixel must be selected. And that selection is based on the decision parameter. So our aim is to derive the decision parameter, and that is based on the distance d1 and d2. What is d1? So d1 is this distance, that is y minus yk. So this is yk and this is y. So d1 is y minus yk. Now how will you determine y? Y is the, actually xk plus 1 y is on the line path. So it satisfies the equation y equal to m into xk plus 1 plus b. Okay. So we will be getting d1 equal to y into, d1 equal to m into xk plus 1 plus b minus yk. Now what about d2? d2 is this distance, that is yk plus 1 minus y, that is yk plus 1 minus y. So this will be equal to yk plus 1 minus y. Y is mxk plus 1 plus b. So this will turn to minus m into xk plus 1 minus b. Now you can take the difference d1 minus d2. So this will be equal to d1 is m into xk plus 1 plus b minus yk minus d2. Minus d2 is minus yk minus 1 plus m into xk plus 1, this quantity, plus b. So this is the difference d1 minus d2. So you can rewrite this equation. You are having mxk plus 1 2 times, so you can write 2 into twice mxk plus 1. You are having yk twice, so minus 2 yk. You are having b 2 times, so plus 2b. You are having minus 1, minus 1. So this is the difference d1 minus d2. Now again, what happens if d1 minus d2 is less than 0? That is d1 minus d2 is negative. If d1 minus d2 is negative, then that means d2, magnitude of d2 is greater. d2 is greater. So if d2 is greater, if this distance is greater, then actual line path will be closer to this pixel center, and in that case the pixel selected will be xk plus 1 yk. That is, the pixel in lower scan line will be selected, or pixel in lower scan line will be closer to actual line path. So if d1 minus d2 is lesser than 0, the pixel selected will be xk plus 1 yk. Again, if d1 minus d2 is greater than 0, if d1 minus d2 is greater than 0, then it is pretty clear that d1 is greater than d2. In the sense, d2 is lesser than d1 and this pixel is closer to actual line path. So the pixel in the scan lane yk plus 1 will be selected, plotted. So this pixel is closer to actual line path. Now what happens if d1 minus d2 is equal to 0? If d1 minus d2 is equal to 0, then both pixels are equidistant from this point, actual line path. And since we are treating line with positive slope, we will be giving higher preference to the pixel in upper scan line. So the pixel selected will be xk plus 1, yk plus 1. So I can summarize this as if d1 minus d2 is less than 0, this is the pixel selected, else the pixel selected will be this one. Okay. Now let us derive the decision parameter pk. Pk is equal to delta x into d1 minus d2. So this will be equal to delta x into, let me expand this m, delta x into 2 into delta y by delta x into xk plus 1 minus 2 yk plus 2b minus 1. So this will be equal to, so I can multiply it with delta x, so I will be getting 2 delta y xk plus 1 minus 2 delta x yk plus delta x into 2b minus 1. So this is our decision parameter pk, that is decision parameter at kth step. Now you have to determine, so if pk is negative, at this point also we can rewrite this thing based on pk. If pk is less than 0, the pixel selected will be, if pk is less than 0, then it is clear that d1 minus d2 is less than 0. d1 minus d2 is negative. So the pixel selected will be xk plus 1 yk. Else the pixel selected will be xk plus 1 yk plus 1. So that is the basis of this Bresenham's line drawing algorithm. Now, based on the kth decision parameter, you will be plotting the k plus 1th point, and after plotting k plus 1 point, you are expected to determine k plus 1th decision parameter, that is pk plus 1. So what is pk plus 1 based on pk? Replace k with k plus 1 in this relation. So you will be getting delta 2 delta y xk plus 1 plus 1 minus 2 delta x yk plus 1 plus delta x into 2b minus 1. Now, in order to determine pk incrementally based on the previous decision parameter, you have to consider pk plus 1 minus pk. What is pk plus 1 minus pk? So you will be having 2 delta y xk plus 1 minus 2 delta x yk plus pk plus 1 minus pk. So 2 delta y into xk plus 1 plus 1 minus 2 delta x yk plus 1 plus delta x into 2b minus 1 minus this quantity, that is minus 2 delta y xk plus 1 plus 2 delta x yk minus delta x into 2b minus 1. So we have subtracted pk from pk plus 1. So 2 delta y xk plus 1 plus 1 minus 2 delta x yk plus 1 plus delta x into 2b minus 1 minus 2 delta y xk plus 1 plus 2 delta x yk minus delta x into 2b minus 1. Now, this will be equal to, so what about xk plus 1? As I said earlier, since we are sampling exact unit intervals, xk plus 1 will be xk plus 1. So you have to increment x by 1. So 2 into delta y, I can expand this as xk plus 1 plus 1. Okay, so I have considered this one minus 2 delta x. We cannot replace yk plus 1 with yk plus 1 or yk. That will be purely based on the previous decision parameter. So we will be leaving this as such, minus 2 delta x yk plus 1 plus delta x into 2b minus 1 minus 2 delta y xk plus 1 plus 2 delta x yk minus delta x into 2b minus 1. So if we go through this equation, you can cancel these two, delta x into 2b minus 1 and minus delta x into 2b minus 1. Then this will be equal to 2 delta y into xk plus 1. I am expanding this one plus 2 delta y into 1. So 2 delta y minus 2 delta x yk plus 1 minus 2 delta y xk plus 1 plus 2 delta x yk. So from here you can cancel these two. 2 delta y xk plus 1 and minus 2 delta y xk plus 1. So this will be equal to 2 delta y, this term, and I can combine these two terms, plus 2 delta x into yk plus 1 minus yk. So I have taken 2 delta x outside. Okay, it will be written like this. I am taking minus 2 delta x outside. So I will be getting yk plus 1. So here I am taking minus 2 delta x outside. So that will be minus yk. I can write pk plus 1. Pk plus 1 is equal to pk plus 2 delta y minus 2 delta x into yk plus 1 minus yk. So once if you are having pk, the next decision parameter pk plus 1 can be incrementally computed from pk, that is pk plus this quantity. Now the question is regarding yk plus 1. So that is actually dependent on pk. So I can write like, if pk is less than 0, pixel or point plotted, or you can write point pixel selected is xk plus 1 yk, xk plus 1 yk, and the next decision parameter pk plus 1 will be equal to pk plus, so at kth step you are having decision parameter pk. If it is less than 0, the next pixel selected will be xk plus 1 will be equal to xk plus 1 and yk plus 1 will be equal to yk. That is, at k plus 1 step you will be selecting this particular pixel. So yk plus 1 will turn to yk. So what about new decision parameter? Pk plus 1 will be equal to pk plus 2 delta y minus 2 delta x into yk minus yk. So this term will become 0. Okay. So the next decision parameter will be pk plus 2 delta y. If this condition is not satisfied, else the pixel selected is xk plus 1 yk plus 1. So what about pk plus 1? Pk plus 1 equal to pk plus 2 delta y minus 2 delta x into, what about yk plus 1? Yk plus 1 is yk plus 1 minus this yk. So this yk get cancelled. You will be getting pk plus 2 delta y minus 2 delta x. So in this way you can incrementally compute the decision parameter. That is the main point in Bresenham's line drawing algorithm. You are having line with endpoints x1, y1, x2, y2, and assume that you are loading the first endpoint into x0, y0. So you are plotting x0, y0 at first, and based on x0, y0 you have to determine the starting decision parameter p0. So how will you compute the starting decision parameter p0? you are having pk equal to 2 delta y, pk equal to 2 delta y xk plus 1 minus 2 delta x yk plus delta x into 2b minus 1. Okay. Now what is P0? P0 from this equation. Replace k with 0. So you will be getting P0 equal to 2 delta y x0 plus 1 minus 2 delta x y0 plus delta x into 2b minus 1. So let me take delta x outside. So if I take delta x outside, delta x into 2 into delta y by delta x into x0 plus 1 minus, since I am taking delta x here, if I am taking delta x outside, you have to divide it by delta x. Here we are taking delta x outside, so you will be getting 2 into y0 plus, since I am taking this delta x outside, I will be getting 2b minus 1. Okay. Now this will be equal to delta x into, so this is actually m, so I can write 2m into x0 plus 1 minus 2y0 plus 2b minus 1. So this will be equal to delta x into 2, I am expanding this, 2m into x0 plus 2m minus 2y0 plus 2b minus 1. So what happens if I am grouping these two? So this will be equal to delta x into, I am grouping 2mx0 plus 2b. Okay. So I am taking 2 outside, 2 into, okay, 2 into mx0 plus b minus 2 into y0 plus 2m minus 1. So this will be equal to delta x into, so what is mx0 plus b? mx0 plus b is actually y0. So that is based on the slope intercept equation, y equal to mx plus b. Since our line satisfies this equation, for the initial point x0, y0, it also satisfies the equation. So it satisfies the equation y0 equal to mx0 plus b. So mx0 plus b is same as y0. So if you take 2 times mx0 plus b and subtract 2 times y0, this term will become 0. Okay. So when that term turns to 0, the remaining will be 2m minus 1. So once more I will repeat, this quantity is same as that of y0. So 2 times this quantity is same as that of 2 times y0. So this will be equal to, if I expand this one, if I replace m with delta y by delta x and multiply it with delta x, I will be getting 2 delta y minus delta x. So this is the starting decision parameter. This is the basic outline of Bresenham's line drawing algorithm. Or you can treat this as the 4th step, and as 5th step you can write like repeat step 4 for k varying from 0 to dx times. So dx steps. So this actually works for line with positive slope with m less than 1. So what happens if m is greater than 1? if m is greater than 1, so we are talking about line with positive slope. If m is greater than 1, it is clear that delta y will be greater than delta x. In that case, actually you have to sample y at unit intervals and determine corresponding x values. So here the role of x and y get interchanged. In the sense, starting decision parameter will be 2 dx minus dy in that case, and if so, here it will be pk, and if pk is less than 0, you have to plot the pixel xk yk plus 1, and pk plus 1 will be pk plus 2 delta 2 dx. Otherwise, plot the pixel xk plus 1 yk plus 1, and new decision parameter will be pk plus 2 dx minus 2 dy. That is for line with positive slope and m greater than 1, that is delta y greater than delta x. If delta x is greater than delta y is greater than delta x, interchange the role of x and y. Then what happens for line with negative slope? So if you consider line with negative slope, so let this be x1, this be x2, this be y1, and this be y2. So line with negative slope and modulus of dx greater than modulus of dy. So, or you can say that line with negative slope with modulus of m less than 1. Modulus of m less than 1. That means modulus of dx greater than modulus of dy. In that case also you have to sample x at unit intervals. The only difference is that y value will get decremented. As we move from left to right, x get incremented. So this procedure will work properly except at this point. So you have to decrement y by 1. Now this algorithm will not work for line with zero slope, that is for line with lines that are vertical and horizontal. So after reading the endpoints, you have to verify whether line is not vertical and not horizontal. If line is vertical, you just keep x unchanged and increment y by 1. If line is horizontal, you have to keep y stationary and increment x 1 by 1. So for negative slope line, you have to just alter this procedure in such a way that you have to decrement y by 1. And again, for line with negative slope with modulus of m greater than 1, if modulus of m is greater than 1, then that means modulus of dy is greater than modulus of dx. In that case, you are expected to sample y at unit intervals. You have to sample y at unit intervals. In that case, you have to interchange the role of x and y, as I said earlier. So this will become 2 into dx minus dy. Here, at this point, x value will remain same as xk, and y value will get decremented because we are moving from left. While we move from left to right, y get decremented. So all those are actually special cases. So from the implementation point of view, before implementing, you have to expand this algorithm by addressing all those cases: vertical line, horizontal line, then line with positive slope with modulus of m less than 1, line with positive slope with modulus of m greater than 1, line with negative slope with modulus of m less than 1 and greater than 1. That's it.